Hey everyone, welcome back to another explainer. Today, we are doing a complete overview of a fascinating new research paper that sits literally at the bleeding edge of artificial intelligence evaluation. We're going to be looking at a brand new framework called WBench. Now, if you've been following the massive explosion in AI lately, you know that generating text and static images is kind of starting to feel like old news. The real new frontier is video, and specifically interactive video. But how do we actually measure success in this totally uncharted territory? Well, that is exactly what this paper sets out to solve. So let's dive into this with a massive question that the researchers are tackling head on. If an AI builds an entire interactive world, how do we know if the physics and the basic rules actually work? I mean, it's one thing for an AI to generate a cool 3-second clip of a dog running across a park. It is an entirely different beast when that AI generates a playable, interactive environment where your actions actually have consequences. Seriously, how on earth do you test an infinite number of possibilities?
Section 1. The World Model Problem, Testing AI Realities.
Okay, to really grasp why testing these generated realities is such a monumental challenge, let's establish a quick baseline. What exactly are we talking about here? Well, interactive world models are advancing at just a breakneck pace right now. Essentially, these AI systems are creating playable digital environments totally on the fly. You got to think of it less like a movie projector playing a video and much more like a real-time video game engine, or even like a sci-fi holodeck. You give the AI an input and boom, it generates a world that you can actually step into and interact with, where the environment responds dynamically to the choices you make. But here is the kicker. And this is the critical flaw this research paper zeroes in on. Testing these models right now is just incredibly chaotic. Existing benchmarks only cover a tiny fraction of the required competencies. Like, they might test if the video looks highly realistic, but they'll completely ignore whether the physics make any sense at all when you try to, say, walk through a door. This leaves the whole industry with this very incomplete picture and, worst of all, absolutely no unified standard for systematic evaluation. It is quite literally the Wild West out there. Section 2. Introducing WBench, a unified benchmark. To fix this massive testing problem and bring in some actual sheer rigor, WBench was built on a scale that is just wild. It starts with 289 distinct test cases. And we aren't talking about simple true or false questions here. Every single one of these 289 cases specifies a completely unique world setting. We're talking wildly diverse scenes, completely different artistic styles, various subjects, and tests that demand both first-person and third-person perspectives. It basically forces the AI to prove that it can handle a huge variety of scenarios, not just the exact same ones it was heavily trained on. But, a static setting just doesn't cut it for an interactive world. So within those 289 settings, WBench maps out a staggering 1,058 multi-turn interaction sequences. Now, pay close attention to that phrase, multi-turn. This means the AI isn't just evaluated on one single isolated action. It actually has to maintain the integrity of the world over an entire sequence of interactions. You open a door, you walk inside, you pick up an object on a table. The world has to remain totally coherent, turn after turn after turn. And the researchers utilized this massive, incredibly demanding testing ground to evaluate 20 state-of-the-art interactive video models. They didn't just cherry-pick one or two proprietary systems. They did a massive sweep of the entire industry to get a comprehensive, totally objective snapshot of exactly where interactive video AI stands right at this very moment. So, the crucial point to take away from this overview is that WBench finally provides the very first comprehensive, unified standard for seeing how well these AI-generated universes actually hold together. It bridges that massive gap between basic video generation and true interactive world building. And it does it by providing this rigorous, systematic methodology that anyone in the industry can use to see if their AI actually understands the world it's trying to simulate. Section 3. The 5 dimensions of valuation metrics. So how exactly do you go about grading an AI on its world-building skills? Well, the researchers evaluate these models across 5 core dimensions. First up, video quality. Does it actually look good? Second, setting adherence. Does it actually follow the initial prompt or the rules of the environment? Third, interaction adherence. If you tell the subject to jump, does it actually jump? Fourth, consistency. If you turn around and then look back, is the room still there, or did the AI completely forget about it? And fifth, physics compliance. Do basic things like gravity, momentum, and object permanence function the way they should? And honestly, this brilliantly illustrates that video game analogy we talked about earlier. You can really think of WBench acting like an ultra-rigorous game tester. It's in there making sure the graphics aren't glitching out, ensuring the rules of the level are being strictly followed, and, perhaps most importantly, checking that the physics engine isn't going to suddenly let you walk through a solid brick wall. If an AI fails on literally any of these fronts, the entire illusion of the interactive world completely shatters. Section 4. The Testing Ground. Inside WBench. Now, you might be wondering, how exactly do they test these vastly diverse environments? Workbench handles this by rigorously testing 4 complex interaction types: navigation, subject action, event editing, and perspective switching. But the real genius here is how it handles the inputs. For things like navigation, Workbench unifies all these different input interfaces. It uses text prompts, 6 degrees of freedom pose control, and discrete action control. This completely levels the playing field, enabling the fair and systematic evaluation of entirely different models, regardless of what their native input interfaces happen to be. The actual evaluation process boils down to 3 steps. First, the model has to execute the multi-turn interaction sequence. Then comes step 2, which is super fascinating. WBench uses 22 automatic submetrics to grade the AI. To pull this off, they cleverly combine specialist vision models with large multimodal models. So they basically have AI act as the referee for the AI that's being tested. But, and this is key, they don't just trust the machine blindly. Step 3 ensures all these automatic metrics are strictly validated against actual human judgments, just to guarantee they align with what a real live person would experience.
Section 5. The Final Verdict. Model Performance.
So, after running 20 cutting-edge models through this grueling multi-turn obstacle course, what did they find? Well, here is the absolute most surprising revelation of the entire paper. Absolutely none of the state-of-the-art models aced the test. Seriously, no single model performed strongly across all 5 dimensions. Some models had incredible video quality, but completely face-planted when it came to physics compliance. Others nailed the interactions perfectly, but then totally lost consistency after a few turns, essentially hallucinating their environments into absolute chaos. But hey, this isn't necessarily bad news. In fact, it's exactly why this research is so incredibly important right now. While no model is perfect just yet, WBench provides incredible diagnostic insights. By breaking down the performance into these highly specific categories, WBench maps out the exact characteristic strengths, the unique weaknesses, and big open challenges for every single model tested. It basically transforms a vague feeling of, this AI feels kind of glitchy, into a precise, actionable roadmap for developers to go in and fix their systems. Which brings us to the ultimate takeaway from this explainer. We finally have a unified standard. Now that we have a rigorous multi-turn testing ground for AI-generated universes, the benchmark has been officially set. WBench has thrown down the gauntlet, and now the race is truly on to see which developers can refine their systems, fix those weird physics glitches, and be the very first to truly master the creation of a flawless interactive world. The tools to measure success are finally here. Now we just have to wait for the models to catch up. So I leave you with this. How do you think these virtual physics engines are going to shape our digital experiences in the years to come? Thanks so much for joining me on this deep dive. See you next time.